The first method that we're going to go over for solving quadratic equations is by factoring. Now, before we solve by factoring, I want us to understand what we are doing, or technically what we are undoing. And what we're undoing is when I am multiplying two binomials together. So if I had these two binomials, and hopefully you've done your module 2 skill review and you have practiced multiplying binomials. But when we multiply binomials, we use FOIL. So we want our first, what if I could spell, would be most helpful. We want our first terms. So my first terms are this x and this x. So x times x gives me x squared. Then we want our outer terms, which is x times 10. So it's going to give me 10x. Then we want our inner terms. So it'd be 4 and x to give me 4x. And then I want my last terms, which would be 4 times 10 to give me 40. So then we would combine our like terms and we would get x squared plus 14x plus 40. Hopefully you've practiced that again in your Module 2 skill review. So now what I'm needing to do when I am solving quadratic equations by factoring is I am now needing to go in the opposite direction. So rather than starting with two binomials and using FOIL, first, outer, inner, last. Now I am starting here at this quadratic, x squared, and I need to figure out what two binomials did I multiply together to get this. So that's the goal when I am solving by factoring. So here are our steps when we solve quadratics by factoring. First, we need to put it into standard form, which means that the equation needs to equal 0. So for example, A is in standard form since it equals 0. B is not in standard form because it does not equal 0. The next thing I want to do, if I can, is factor out a GCF. Then we will factor, and we will factor by using the x. And then we will use our zero factor property to solve. So starting with example A here, I just discussed it's already in the standard form and I have no GCF here. And what I'm looking for in a GCF is, can I divide something into all three terms? So I can't divide anything into 1, -11, or 24. So we're starting right here on step 3, factoring, and we factor by using our x. So this is technically called the diamond method, but I'm going to use just an x here. And the first thing I want to do is multiply together my a and my c terms. So my a right here is 1. If I don't see anything, that's an a of 1 times my c term of 24. So 1 times 24 gives me 24. And I'm going to write my b term down here, which is -11. So then I want to ask myself, what two numbers, when I add them together, add up to -11, but when I multiply those same two numbers together, I get +24. If you're not good at your multiplication, this might be difficult for you to do. So what you're going to have to do is list out your multiples of your a times c. So my a times c is 24. So what numbers do I multiply together to get 24? Well, that would be 1 times 24 or -1 times -24. When I add those numbers up though, what do I get? Well, 1 plus 24 gives me 25. -1 plus -24 is -25. So neither of those add up to -11. So keep writing your multiples of 24. We can do 2 times 12 or -2 times -12. This adds up to 14. This adds up to -14. So I'm getting closer to this number, but not there yet. The next one we can do is 3 times 8 and -3 times -8. When I add these two numbers together, we get 11. When I add these up, we get, and that should be a -8, we get our -11. So I have found my two numbers here. So this is -3 and -8. Okay, if this one still didn't work, we'd have to keep going, and you can do 4 times 6 or -4 times -6. But if you cannot look at this and say what multiplies to this and adds up to this, you have to list out your multiples of your A times C and then figure out which one adds up to the B you need. So now that I have figured out what adds up to my AC and what multiplies, or sorry, goodness, what multiplies to my A times C but adds up to my B, now I can factor this. This would be X minus 3 times X minus 8. So now I have factored. So now I'm going to use that zero factor property to solve. That states that if this times this equals 0, then at least one of them must equal 0. So I will take X minus 3 and set that equal to 0. We would add our 3 over, and we get X equals 3. Same thing here, X minus 8 equals 0. Add your 8 over, and we get X equals 8. So notice I have two answers. When we have linear equations, we only have one answer. When I have a quadratic equation, we can have, and most of the time we will, have two answers. And I can see I'm going to get two answers because it's an x squared. So if I go on to harder ones and we get an x cubed, we could have 3 answers. If I get an x to the 4th, we could have 4 answers. And so whatever that exponent is tells me how many answers I could possibly have. Let's continue on and do part B here. And I'm going to change colors just so we can kind of keep these separate. So part B, we're going to need to use all of these steps here. First, I can get it into standard form. This one equals 0. So I need to move this over to the other side. And I can't just pick up that 30 and move it to the other side. We always have to do the opposite operation. So I am going to subtract 30 over. And so now I have 6x squared plus 24x minus 30 equals 0. So now it equals 0, so it is in standard form. Now we need to pull out our GCF. So I'm looking at all 3 of these terms. What number can I divide out of all 3 terms? Now, they are all even, so if you said 2, that is a CF. That's a common factor, but it is not the greatest common factor. If you said 3, same thing, it's a common factor, but not the greatest. The greatest common factor here is 6. All 3 of these numbers are divisible by 6. So I'm going to pull a 6 out. And then what do I have left? So when I pull that 6 out, what I am essentially doing is dividing each of these terms by that GCF. So 6x squared divided by 6 is just x squared. 24x divided by 6 is a positive 4x. And negative 30 divided by 6 is a minus 5. Okay, when I pull out that GCF, what I'm doing is I am undoing the distributive property. So you can easily check this. If you distribute that 6 back into everything, you get back up to the top. So 6 times x squared is 6x squared. 6 times 4x is 24x. And 6 times a negative 5 is negative 30. Now that I have pulled out that GCF, now we're ready to factor, which is our x. So my A times C, I'm not looking at my big trinomial with all of the bigger numbers. I'm looking at this one here with the smaller values. My A is 1, my C is negative 5. So my A times C is negative 5, and then my B term is 4. So what adds up to B but multiplies to AC? Hopefully you can see this, but if you can't, you're going to have to list them out. Now, negative 5 is easy because that's a prime number. So that is either 1 times negative 5 or negative 1 times positive 5. So what do these add up to? Well, this one adds up to -4, and this one adds up to a +4. So what is my correct multiple is this one right here. So we have -1. So the 6 is just going to carry on down here with me. And now this factors to x minus 1, x plus 5. So I'm going to take this, x minus 1 equals 0. So we get x equals 1. And here we get x plus 5 equals 0. So x equals -5. So still two answers because I have an x squared. Now, something I probably should have showed you here on part A is that you can check your answers by just plugging these values in. So for this one here, if I say that x equals 1, I'm going to plug in a 1 to both of these x's. So I have 6 times 1 squared plus 24 times 1. Why did that not work? Oh, my goodness. Okay, because it's a plus 24. Oh, okay. So 6 times 1 squared plus 24 times 1 gives me 30. Are you guys screaming through the video? Okay, and then check the next one here. We would have 6 times -5 squared plus, that's helpful, 24 times -5, and we still get 30. So when you plug them in, the equation is true. Same thing over here. If I plug in 3 to both of these x's, we would have 3 squared minus 11 times 3 plus 24, and we got 0, which is what this equation here equaled. Now, if I plug in an 8, we get 0. So you can plug these in and check your answers. Now, we do have one more example of solving quadratics by factoring, but I actually want to stop the video here because in this video here, both of these trinomials are considered easy trinomials. So I'm going to put easy in quotes. These are considered easy trinomials. Okay, and what makes these quote easy trinomials is that both these have an a that equals 1. So right here, this was a 1x squared, so a was 1. Here, it didn't start out as an a of 1, but because I could take that out as a GCF, right here, we had an a of 1. So when we have an easy trinomial, this is our method of when we figure out what goes in this box right here, when we figure out what multiplies to our AC and adds up to our B, it just factors to x plus or minus those numbers, x plus or minus those numbers. When we go on to the next video, we're going to have what is considered a quote hard trinomial. And it is not hard, but it does require some extra steps. So make sure you understand easy trinomials before you go on to hard trinomials that have more steps.